We're going to take out the greatest common factor out of this binomial, 30y to the 12 plus 25y to the 9th. We're going to look at the coefficients, the 30 and the 25 first, and take out the biggest number that's common to both of those. And then we're going to look at the variables and see the largest that we can take out there. So looking at the 30 and the 25, 5 is the biggest number that will divide evenly into 30 and 25. I'm going to leave a little space there because if I divide 30 by 5, I'm going to get 6. And if I divide 25 by 5, I'm going to get 5. So now we've got to look at the y's. It's the greatest common factor, but we don't want to take out y to the 12th because you can't take out 12 y's if you only have 9 y's. So greatest common factor, you take the smallest exponent. So there has to be a y in both terms. So if the 30 didn't have a y to the 12th or a y in it, you couldn't take out a y. But there's a y in both terms. You take out the smallest. And that means you're dividing each of these by 5y to the 9th. Because that is your greatest common factor. So 30 divided by 5 gives us 6. Y to the 12th divided by y to the 9th. The base is the same, you're dividing, so you subtract. You take those 9 away from the 12, so that's going to leave you y cubed. Bring down the plus. 25 divided by 5 is 5. And y to the 9th divided by y to the 9th, that is going to cancel out because 9 minus 9 is 0. Anything to the 0 power is 1. So y to the 0 equals 1, and 1 times 5 is 5. Now, all of this has to go in your answer blank. Not just what you take out, but the entire answer, because all of this has to multiply back to that original 30y to the 12th plus 25y to the 9th. You can use distributive property to check it. 5 times 6 is 30, y times 9, y to the 9th times y cubed. 9, 10, 11, 12, that goes back to y to the 12th. 5y to the 9th times 5 goes back to 25y to the 9th. So it checks. This one we're going to factor a trinomial. The first thing you want to do when you're factoring trinomial, make sure it's in order. So we have the squared term first, then the b term, and then the constant term. So b squared minus 7b minus 30. That's in order. If you look at the exponents, that's 2, 1, 0, because on that 30, b to the 0 is 1, 1 times 30 is 30. So we're going to take out a greatest common factor. Well, we can't take out a b because there's not one in that last term. That negative 30 doesn't have a b. So we can't take that out. And coefficients are 1, 7, 30, so nothing there common. So no greatest common factor. It's 3 terms, and the first term is a 1b squared. So that means that's the easiest one. We're just going to look at the last number and the middle number because we're doing the opposite of FOIL here. This is called reverse FOIL, basically. Remember the first, outside, inside, last. We want to make it look like that so that if we were to multiply it, it'd go back to b squared minus 7b minus 3. So if we multiply the first terms, b times b, that's going to give us b squared. That's good. Now, the last term, it's a negative 30. So that means these terms in the end have to multiply to give us negative 30. So we know the signs have to be different, right, to get negative 30? Because a positive and a negative is the only way you can multiply and get negative 30. So numbers that multiply to give us 30 are 1 and 30, 2 and 15, 3 times 10, 4 won't go, 5 times 6, and I'm back at 6. Now, most of the time you can just look at this and tell, oh, it's got to be this number or that number. If not, go in order, divide 1 into the number 2, see if that'll go, and go that way until you get back to the number and you start going the opposite way. So we want numbers that multiply to give us negative 30. Because this right here is a minus, right here, whoops, right here is a minus, that means we want to subtract to get that negative 7b. So we have to have ones that subtract to give us a negative 7b. Now notice I didn't put any signs here. I'm just looking at what will subtract to give me a 7. Well, that's a 3 and a 10, and you'll only have one set that will work. One set or no sets will work. Usually it's just, there's not very many where nothing works, where it's prime. So 10 minus 3 is 7. Now I want it to be a negative 7, so that means it would have to be a negative 10 and a positive 3, right? Because negative 10 times positive 3 is negative 30. Negative 10 plus 3 gives us a negative 7, and that's what we want, that negative 7b. So we're going to have plus 3 and minus 10. So plus 3 and minus 10. And it doesn't matter if you put the minus 10 first and the plus 3 in the other one, because that first term is the same. And now if you want to check it, and if you're new to factoring, I would suggest checking because it helps you get down the steps and know where the numbers are coming from. So to check it, we just do FOIL. Whoops, sorry about that. So b times b, the first, that gives us b squared. B times negative 10 gives us a negative 10b. Then 3 times everything in the other set, so that's positive 3b. And then 3 times negative 10 is negative 30. Last term checks, that's a negative 30. First term is a b squared. And these right here give us a negative 7b. So everything checks. And what I put in the box, that's what you'll put in the answer. And sometimes in your answer, like if you miss an answer and you look and you hit the little key button and it shows you the answer, there might be a dot in between the b plus 3 and the b minus 10, but you don't need the dot there. So we're going to factor some more problems here. 4x squared minus 9. Make sure it's in order, highest exponent first. With this one, there's two terms, and there's a subtraction, so you want that in the middle. This is called the difference of squares. So there's not a common factor we can take out because there's not an x in both terms. 4 and 9 have nothing in common. It's two terms, so it's either going to be the difference of squares or it's going to be the sum and difference of cubes. Since it's a square, perfect square, 4 is a perfect square, 9 is a perfect square, we're going with difference of squares. You can only factor the difference of squares. You can't factor the sum of squares, only the difference of squares. And this is a real easy one to factor. There's steps that you're going to do. It's going to be the same whenever you see two terms. Both terms are perfect squares, including the variables, and it's a difference. There's a minus in the middle. So the square root of 4x squared, well, the square root of 4 is 2, and to take the square root of a variable, we're going to divide that by 2, so that would be x. So let's check. 2x times 2x goes back to 4x squared. The last term is a negative, so that means one has to be a plus and one has to be a minus. The square root of 9 is 3. So notice these are both the same except one's the sum and one's the difference. So let's do check with FOIL. 2x times 2x is 4x squared. That checks. 2x times negative 3 is negative 6x. But notice when we do the 3 times 2x, we get plus 6x. So these are going to cancel. And then 3 times negative 3 is negative 9. So that goes back to 4x squared minus 9. And it'll only do that if that's the difference, if that's a minus there. Move that dot. So this is our answer. We're still factoring, but notice there's 4 terms. So with 4 terms, you're automatically going to do factor by grouping. And I would suggest that you group it in the order that you see it. If it doesn't work out, then move the order around. So just start by grouping the first 2 together and the last 2 together. If that doesn't work, then we'll switch them around. So looking at the first 2 terms, the xy and the 5y, The only thing common in those first two terms is y. So I'm going to take out a y. That means I'm dividing this term by y and this term by y. And I'm just looking at the first two terms. I'm grouping the first two together. So that's going to leave me an x plus 5 in parentheses. And if I multiply it back, y times x goes back to xy. Y times 5 goes back to plus 5y. Bring this sign down automatically. And then look at your 3x and 15. What is common there that you can take out? Well, 3 will go into both of them. You can't take out an x because x is not with the 15, but you can divide both of those by 3. Now, this is where you have to be careful. When you have a negative here, remember, you're dividing both of these by not just 3, but negative 3. So that's very important when you bring down that negative sign. Now, if that had been a plus, you just bring down the plus. It doesn't, you don't usually make a mistake. It's when it's the negative. This first term now is going to be positive x, because negative 3x divided by negative 3 gives us a positive x. Negative 15 divided by negative 3 gives us a positive 5. We can check it to make sure. Negative 3 times x goes back to negative 3x. Negative 3 times positive 5 goes back to negative 15. So we know that works. We also know we're good because what's in parentheses is the same thing. If it's not the same, it's not right. Okay? It has to be the same in parentheses. So since those are the same, we can factor that x plus 5 out. So I'm going to take x plus 5 out, keep it in parentheses. And then what's left over will go in the other set of parentheses. So I'm dividing this term by x plus 5 and this term by x plus 5. So what happens, these cancel, and that leaves us what's on the outside in the other set of parentheses, y minus 3. Now, if I were to check this, so this is my answer. Now if I'm to check it, whoops. I'm going to check with FOIL. X times y is xy. X times negative 3 is negative 3x. 5 times y is plus 5y. 5 times negative 3 is negative 15. Notice it goes back to what I started with. The only difference is they may be in a different order. It's still a positive 5y and a negative 3x. It's just when I checked it, the negative 3x came first. That does not matter. So this one does check. So this is our answer right there.